Good morning, everyone. My name is Scott Oakley, and I'm the Technical Manager at Glasscorp. The subject of today's webinar is Glazing Putty application. In this presentation, we'll introduce the Glasscorp range of glazing putties and dive a bit deeper into some of the different aspects that comprise a successful putty glaze system. Just a quick overview of the agenda. Firstly, I'll go through the different glazing putties that Glasscorp offer. I'll then cover important substrate preparation steps that need to be done before glazing putty application. We'll then cover important considerations to be made in the selection and application of the paint system before discussing some of the potential pitfalls that can arise in putty glaze systems and how to avoid them. The two traditional linseed oil glazing putties that we make are wood sash, designed for use in timber frame windows, and steel sash, designed for use in steel frames. Both products are available in a range of sizes from small bottles to large buckets. Both wood sash and steel sash have similar formulations, the key difference between them being that products designed for steel frame windows will allow for a bit more movement that can be induced by the thermal movement of steel frames. Traditional glazing putties can take several weeks to sufficiently cure before they are ready to be painted. The standard drying time that we specify in our technical data sheets for both of these products is 6 weeks. However, this of course will vary depending on the conditions the putty is applied in and exposed to while it's curing. In addition to our traditional glazing putty products, we offer faster drying alternatives, XHP wood frame, which we supply in a 1 kilo sausage and in bucket form, and XHP steel frame, which is sold in 1 kilo sausages. The key difference with the XHP product range is that they cure much faster than traditional wood sash, steel sash putties, allowing them to be painted over in only 24 to 48 hours, as opposed to waiting several weeks. For certain projects where time pressures are a concern or where access may be an issue, for example, where scaffolding is being used, XHP is an option available that will allow you to complete the job much faster. I'll point out that there is no difference when it comes to the long-term performance between your traditional putties and XHP variations. In addition to glazing putty, we also supply a range of tools, fastenings, and base components. These include application tools such as putty knives and point drivers, XHP bedding compound used to bed in glass for both standard and XHP putty installations. We sell diamond points and push points for timber framed installations and steel clips for steel frame applications. We also supply a few base components such as raw linseed oil and whiting powder. In this next section, we will talk about the importance of proper substrate preparation prior to the application of putty. Starting off with timber frame applications. Any surfaces that are to be glazed must be sound, clean, dry, and free from grease, dirt, and any other loose material before application. If you're refurbishing or reglazing old timber windows, you'll need to ensure that all old and cracked putty and paint is fully removed and any uneven surfaces are sanded down. All bare timber should be primed with a suitable oil-based or alkyd primer and allowed to dry. Priming adds a layer of protection to the timber and helps the putty better adhere to the frame. Be aware that being a porous substrate, there will be some oil migration from the putty mass into the timber. This is expected and helps promote normal oxidation rates of the putty. A thin coat of primer should still allow this to occur. While it is important that timber joinery is primed before putty application, we also need to be careful that surfaces are not over-primed, as an excessive buildup of primer can actually slow down putty cure and lead to subsequent failures in the system. This is something to be aware of when installing new timber windows, as often timber joinery, when it arrives, will have already been primed by the supplier. For steel frame windows, the same key points apply. Surfaces must be sound, clean, dry, and free from any loose material, including rust, which may be present in older steel frame windows. If you're refurbishing or reglazing old steel frame windows, you'll need to ensure that all old cracked putty and paint is removed, and any rust that may be present is fully removed and treated. In more severe cases, this may require wire brushing or the use of a specific rust treatment to remove. Prime the bare metal frames with a suitable primer and allow it to dry. Again, this adds a layer of protection to the steel frame and allows for better adhesion of the putty. Now that you have primed and prepared your substrate, the next step is the actual window installation and putty application. I'll run through the basic steps involved and important considerations that should be made. For timber frame installations, bed the glass into place. Now you can do this using either the putty itself or our XHP bedding compound. This comes in a cartridge for easy application. Secure the glass into place using diamond points or push points. A reminder here that the glazing putty itself is not a structural medium, it's the fasteners which hold the glass in place. Ensure the putty is uniform in consistency before applying it. Use a clean putty knife to firmly press the putty into the cavity and smooth it off. Timber fillets may be used to control the thickness of the putty bead when required. An ideal putty thickness is about 12 millimeters, as shown here. Putty that is excessively thick will fail to properly cure through, which can lead to soft and wrinkled putty. We don't supply timber fillets, but our technical data sheets have more guidance on when and how these should be used. And now for steel frame windows, the same principles apply. Bed the glass into place using putty or XHP bedding compound. In this example, the glass is resting on top of a setting block as opposed to directly on the steel frame. Secure the glass into place using steel glazing clips. Ensure the putty is uniform in consistency before applying it. Use a clean putty knife to firmly press the putty into the cavity and smooth it off. And finally, just like timber frame glazing, timber fillets may be used to control the thickness of the putty bead when required. A very important factor that will affect the performance of the whole system is ensuring that the putty has adequately cured prior to painting. Now, in our context, when we refer to the curing time or the drying time, we're talking about the time it takes for the putty to cure enough to the point where a firm skin is formed on the surface of the glazing bead that will accept paint. Painting too early can delay the proper curing of the putty mass, causing lengthwise cracking and peeling. On the flip side of this, to delay painting may lead to surface deterioration of the putty bead and subsequent peeling of the paint due to poor adhesion. We really want to avoid leaving cured putty beads exposed for longer than they need to be. If the glazing bead is left for long periods, not protected by that paint coating, it will eventually start to dry out. Curing times will change under different temperature and humidity conditions. Cooler temperatures will extend the curing time. In our product data sheets, we give general guidance on the typical curing times. However, remember, these are just guidelines. Also be aware that it's not unusual to see variation even within different areas or elevations of the same building. For example, it's not unexpected that a north-facing elevation exposed to continuous sun will cure at a faster rate than a south-facing elevation or a more sheltered area on the building. You may make the determination that certain areas are ready to be painted before others. This is where good judgment should be exercised. Now, in this next section, as we discuss paint systems, I'll preface the section by saying that we are not paint suppliers and by no means profess to be paint specialists. However, knowing that the paint forms a crucial part of the putty glaze system as a whole, it is important that we cover some key points. The paint system is essential as it is the paint that acts as the weather seal, protecting the joinery from water ingress. Being a weather seal, it is important that the paint laps onto the glass 2 to 3 millimeters at a minimum. Oftentimes, painters will apply masking tape to the glass to get that few millimeters of coverage. Paint that is not adequately lapped up onto the glass can allow water to enter and get behind the putty, potentially causing water buildup, which can lead to rotting timber sashes and leaking windows. Question that we get asked sometimes is, what paint should I use, or what type of paint system should I use on my putty? Now, while we don't recommend specific brands or products when it comes to paint systems, we do offer some general guidance when it comes to the preferred paint type for putty glazed windows. In the slide, I'll provide a bit of commentary on the differences between the two common paint types and the advantages and disadvantages of both. On the left, we have oil-based or alkyd paint systems. In years gone by, these types of paint systems have been the standard, especially for exterior joinery, due to their hard-wearing finish, resistance to wear and tear in high-contact areas, such as window and door frames. A notable property of oil-based paints is that they typically have a characteristically strong odor, which is caused by volatile solvent content, which is released into the air as the paint film cures. It is for this reason that more recent trends have moved in the direction of water acrylic-based paint systems, as these paints don't have the associated strong smells and are considered to be more environmentally friendly than their oil-based counterparts. One key difference between oil-based and water-based systems is related to the speed at which they dry. Water-based systems are known to dry notably faster than oil-based alternatives. While this is often a desirable trait to have from the painter's perspectives, being able to complete the job faster, not having to wait as long between recoats, for putty glazing applications, this does present more risks for failure, as the faster drying film and the higher degree of shrinkage can induce larger stresses in the paint, contributing to peeling and cracking. It is for this reason that our data sheets will show a tendency to recommend traditional oil or alkyd-based paint systems over water-based systems. Once you've determined that the putty has sufficiently cured to accept paint, prime the glazing bead with a suitable primer and apply 2 coats of a compatible exterior top coat. Avoid excessively thick paint coverage. This can induce greater stress on the paint film due to increased paint shrinkage. Be careful when masking off windows when applying paint. The reason I mention this is that there is a real risk of removing that very thin paint film on the glass when the masking tape is removed. It is important that care is taken if masking tape is used at all. Be conscious of weather conditions when you're painting. This goes to what I was saying in the previous slide. We want to avoid rapidly drying paint films, as this can contribute to cracking and peeling of the paint. And finally, it goes without saying, avoid the use of paint systems which are specifically marketed as fast drying. Finally, in this last section, I will cover a few potential pitfalls to avoid when designing and installing a putty glaze system. And I'll provide some answers to a few of the more common queries I get regarding putty glaze systems. First consideration I'll mention is regards to the glass selection. Our technical data sheets will state that Glasscorp glazing putty is specifically designed for use with clear float glass only. For glazing any other glass types, we recommend contacting the glass supplier for advice before proceeding. We don't recommend putty glazing laminate glass due to possible interactions between the putty and the laminate interlayer. There are certain laminate types, such as PVB laminate, for example, which are susceptible to water penetration, that we would generally not recommend for use in timber frame windows in any case. Now, we are aware that glazing putty applications have been done and continue to be done with laminate glass. However, we aren't able to account for every different laminate type and every type of interlayer. So it is out of an abundance of caution that we state in our technical documentation that we don't recommend this. For tinted and coated glass, we recommend a timber beaded system due to possible complications caused from heat transfer from the glass to the putty mass. Comment that we get every now and then is that the putty is too soft or the putty isn't hardening. I'll be clear that it is a common misconception that glazing putty is designed to set hard. This is not the case. Glazing putty is designed to maintain a degree of flexibility and malleability over its lifespan. The inbuilt flexibility allows glazing putty to accommodate thermal movement and an expansion contraction of the window joinery over time. Now, we've covered in previous slides a few factors related to the application of putty that can inhibit or slow down proper curing, such as putty being applied too thick or putty that is painted too soon. Something unique to timber glazing applications that it is important to be aware of is potential issues that can arise from the use of cedar joinery. Certain types of cedar joinery are known to contain high levels of antioxidants, which can inhibit the proper curing of glazing putty. The inhibition of curing caused by antioxidants in the timber may present itself in the form of random or unexplained soft patches of putty within a single sash or a single window. When we do get advice from customers about visible defects on site, which I'll point out is in a very small minority of jobs, most often in these cases, the defects observed comprise some form of cracking or peeling of the paint after it has been applied to the putty. Peeling and curling away of the paint film from the putty skin can be a result of a few different factors, including poor paint adhesion to the putty and high stresses induced during the drying of the paint film, causing it to rapidly shrink and pull away from the glazing bed. When these issues occur, or really any visible defects occur, there are several questions that should be asked to help determine what factors may be contributing. A few of these include: have the substrates been correctly treated and primed? Has the putty adequately cured to allow for painting? Or conversely, has the putty been left exposed, unpainted for too long? Have suitable substrates been used, including the prescribed paint system? Are the defects widespread or isolated to certain areas of the building? When we're asked to comment on what's causing a specific defect, it can be very difficult to do. As you've seen in this presentation, there are so many different factors that influence the ultimate performance of a putty glaze system, and often when issues are present, it comes down to a multitude of factors. One of the main goals of this presentation is to equip you with information on what is involved in a complete putty glaze system and the importance of different elements and steps, which can be easy to take for granted, to hopefully avoid any of these issues in the first place. Now, just to recap what we've covered today. We've covered the different products in the Glasscorp range and factors to consider when selecting a suitable putty for your job. We've talked about the importance of correct surface preparation before putty is applied. We've gone through the basic steps involved in glazing putty application. We've talked about paint types and important considerations that should be made when applying paint systems. And finally, we've covered a few extra points to be aware of and potential pitfalls to avoid. That brings us to the end of this presentation. Thank you very much for your time today. If you do have any questions on this webinar or any topics not covered, please do not hesitate to contact me. Thank you.